Coming. Quite a large audience. I was a little bit surprised. So quickly just want to talk about BlockApps, our company, our product, and the work we've done with Quorum, JPMorgan Quorum. But Quorum is, it's everyone's Quorum as well. Wait, it's not. Hit the button. Perfect. So to talk a little bit about the company, why we did the technical integration work we did, sort of in the spirit of the Enterprise Ethereum Alliance, and then two of the specific kind of interesting features we built, which you guys can all go use, as this is a mostly developer audience. So quickly on us, as Connor mentioned, we were the first company external to the Ethereum Foundation to build a full compliant version of Ethereum. That's the Haskell implementation. That's formed the basis for our core product, which we call STRATO. I would say we're the co-creator of the concept of blockchain as a service. We launched this with Microsoft in, November of 2015, in which we took our core technology, which was optimized for just easy application development, packaged it on their cloud, and distributed it so that enterprises, in addition to sort of public net developers, could very quickly build applications, et cetera. We have interesting production implementations of our software. Those are sort of rare outside the public net, but we can talk about them. You can grab me later. So in terms of where we see ourselves in the value chain, we see ourselves as sort of built on open protocol standards. We're like a browser for Ethereum, maybe others. So notably, we've sort of added a little bit to Ethereum to make it basically in response to enterprise demand for features that it needs to support, et cetera. Fortunately, the Enterprise Ethereum Alliance exists to sort of standardize additions like the ones we've made to Ethereum so that the enterprises who are worried about vendor lock-in, which is a good percentage of them, can be confident that everything will basically work the same way across different vendor code bases. Again, we've done a fair amount of work with Quorum. But the way our platform works is it's sort of broken into kind of a core layer and an API layer, which is actually relevant to the technical work we've done. But we are unique in that we build the blockchain as many separate processes. It's something of a microservices architecture inside a sort of single blockchain node. And the reason we did this was, in a sense, reactive. When we were first synchronizing with the Ethereum LiveNet and testnet before that, we found the foundation was making sort of very rapid changes to the code, some of which would make it into the spec after they had been coded. And so we sort of changed our architecture in a way that we could very quickly iterate in response to their changes, and the microservices architecture is what emerged. And then we expect mostly third parties to build business applications on top of our platform, and then some of them are vertical specific. So customer base, large number of cloud customers. Then we work with specific enterprise in a higher touch manner, where some of the larger production implementations of blockchain technology have been done. They've been us. So I want to talk about quickly what we did with Quorum and what we might continue to do in the future and why we did this. So Quorum represents sort of the enterpriseization of the public Ethereum code bases in a way that our product also does as well. So we both recognize the need that enterprises need particular features that are not present in the core Ethereum code bases just to even be able to use the technology. Fortunately, Ethereum is a standard. Early on in the Ethereum days, it was decided to make the foundation itself decided to make many different implementations of Ethereum because of problems they perceived with the Bitcoin ecosystem, and that we were locked into a code base and not a standard. And so it was very difficult to define, except by code, what Bitcoin was, should we ever want to make decisions about its direction outside of the core developer group. And so Ethereum decided early on that it would be spec-based, and there would be competing and cooperating implementations of that spec, And fortunately, the spec existed, and so some of what we were able to do was facilitated by having a common protocol that our stuff actually works well with the Quorum stuff sort of out of the box. So non-overlapping feature sets, Quorum has focused more on privacy than we had initially, just due to particular use cases in the banking industry, I assume. We had focused on kind of API usability level questions, but also things we'd encountered in the production implementations we'd done, the need for reporting, basically integrating traditional relational databases as sort of downstream of the blockchain source of truth is just a requirement for business users to be able to query the live data in their production systems, report on it, calculate P&L, that sort of thing. So our product, in a sense, was optimized for that path. Quorum was optimized for a similar but slightly different path, and so we hoped to create some sort of best-of-breed merging of these feature sets. And so this is kind of the idea of the EEA. The EEA is spec-based, but also aimed at having reference implementations of those specs that, in theory, were more together than apart. And so we really tried to do this with some success. Any questions, actually? Let me pause there. No questions. Perfect. OK. So what did we actually do? We solved in, over the period of a few months, 4 key problems, some at more of an MVP level, some more at a production level. So Quorum, for instance, we heard from our friends at JPMorgan, some of whom are in the audience, that there's lots of requests for the ability to query blockchains as if they were relational databases. Given that this was a problem that BlockApps had already solved and had solved more or less in general, and there was a compatible protocol layer, we were actually able to integrate our existing product with Quorum so that this facility kind of comes out of the box. And I'll show you later architecturally how that works and how you can try it. So big general problem that we were able to solve in kind of across 2 code bases by doing a fairly light technical integration. There was work to do, but it was easier than it would have been had there not been a common standard. So yes. Network, say, operations. So we built a tool that, so most permission networks are permissioned in a sort of traditional cert-based manner in which nodes have different identities, sort of like TLS identities, and you can check the IPs and the certs and create sort of a whitelist for who is allowed on a particular network when. And the tooling around this capability is sort of fairly early in that not that many people are really running these networks in production, and so there hasn't been a tremendous market need for really good network management tooling. But we built sort of an MVP product so that a middle office user who wanted to understand the dynamics of a network, permission it, potentially remove people from the network. So imagine sort of an industry market utility rather than, say, a bank who would be monitoring industry, or a regulator even. Industry-wide activity could have the ability to permission the network from a dashboard basis. So this is something we built in sort of alpha form during the work we did. And that's also open source. There's links to it later in the presentation. We made some enhancements to the core innovation in Quorum, which we see as privacy. So there were certain cases in which some data that we didn't want to expose was exposed, and we were able to fix those, so that's great. Finally, we open sourced, so another interesting point on the standard. So our code base is in Haskell. Quorum is mostly in Go, also has some Haskell, also has some other stuff, I believe, probably some JavaScript. Problem with all blockchains, not really a problem, it's sort of a design choice, is that they grow forever. And that's the immutability property. The problem with that, though, is that you need to be able to actually practically use the thing, and the larger the disk consumption is, the more expensive it gets. And typically, the lower the performance is, you have to sort of seek to the end of the blockchain before being able to operate on it. So we have a tool that prunes the state of a blockchain so that it's lighter, so that the performance degrades less over time. And this was actually an existing tool written in our Haskell codebase that we open sourced and happened to be fully compatible with the Go Ethereum state database that Quorum depends on, sort of out of the box, because again, we followed the standard. So just a little bit more on how this was actually done. And it kind of touches on the open source discussion we had before, timely. So we have proprietary software. We're a software company, we sell proprietary software. But we were able to integrate it very nicely with the open source side through sort of a messaging architecture we have. We use Apache Kafka as sort of an internal and somewhat external message bus to allow different pieces of the blockchain to talk to each other. And so what we did is take the state of the Merkle Patricia database, which is kind of all the active accounts and smart contracts sort of versioned over time. And we wrote a small tool that dumps that state in the same format that the rest of our software expects. And then it sort of goes through a pipeline in which it eventually reaches a relational database, both at a per block, per transaction level, and at a per smart contract level. And so we were able to reuse all of that work we did, which is a pretty cool thing. And thinking about the licensing, it was important that we really drew a line because we would otherwise have to open source everything we've done. So interesting, and I think it's important. Again, as a vendor, we need something that's proprietary, that's differentiated, which means you have to be very careful with the GPL code. But I think of it as an interesting case study. And again, you can just check it out here. The integration part is all open source, and you can just download this and use it. If you want to use it in production, you got to call us, though. Just a little bit more on the network governance and how it was achieved, and then you'll see the links to it. So you can imagine a situation in which you've got at least two banks, but there's also a sort of semi-centralized network operator whose only role is to make sure the network has the right participants. And then they're going to be connected over the public internet, but each in their own sort of virtual private cloud. So what we built is sort of a traditional web-based application that permissioned at the network layer and then just allowed nodes entry and then set everything sort of off and running from there. It even had sort of a nice email-based invite flow. So a convenient tool to add participants to networks that are running and manage them after the fact. Again, you can check this out up here. There's some description, more detailed description of the architecture on the right, and you can just test it in your own time. All right, feel free to contact me. Also, Kelly is in the audience somewhere. And we can all, go home, get some food, have more drinks, go to sleep. Thank you. Unless there are a couple questions. I have time for a couple questions.
Got time for, probably one.
Can I ask why do you choose RD relation the database, not the graph database?
Yeah, part of me actually really wants a graph database a lot of the time. A lot of what you're doing in blockchains to calculate the current state is like a tree traversal or a DAG traversal in some cases. They're just not mature enough to really use at any kind of reasonable data size and transaction throughput. We kind of tried it, actually. We didn't try really hard, but it seems that practical graph databases are sort of overlays on existing databases, like Facebook's Tau social search thing is a particular, it's like tons of MySQL, sharded databases that have some kind of caching that allows the traversals to go faster. I wish they worked better, though. I would use a graph database.
Sorry, we're going to have to keep going. Thank you very much, Kieren, for the great presentation. This is really cool to see companies building stuff on top of Ethereum, because that's the area that I think blockchain technology needs a lot more focus. So, thank you.